Hello everyone. In this video, we'll be solving the question target some pair in binary search tree. What does that mean? Say we have a binary search tree like this one. Feel free to verify its validity, whether it is actually a binary search tree or if it's just a binary tree. I say it's a binary search tree. I've verified it. I have this and I've been given some data, say 100. I have to find all pairs of nodes that we can find here such that the sum of that pair gives us this data. So for us, that would mean that is 25 and 75. Then we have 30 and 70. Then we have 40 and 60. I don't think there are any other pairs here. Alright. This will be our answer basically. So, and also one thing to keep in mind is that when we are printing our answer, it has to be in increasing order. So first 25, then 75, first 30, then 70, first 40, then 60. That is the order we'll be printing it in. Now, the idea and how to solve it is to implement a traversal. We'll implement a traversal. We'll check a node. We'll traverse. We'll check our node. We'll calculate the complement of our node. The complement would mean the data that we've been given minus the value of our node. This is our complement. Then we find our complement. I'm just shortening it here. Then we find our complement inside the very tree. If we are able to find the complement, we simply print the pair. That means the pair exists, so we print it. Otherwise, we ignore. We do nothing about it. And to print the pairs in increasing order, as you might be aware of the concept, we will be using the in order traversal. We'll be working in order here. And so we don't have a function, so we'll create one. Let's call it public static target some pair. I'll be passing my root to it. I'll explain why. And then I'll be passing my node that I'll be testing on. And in that particular call, then I have my data here. I have to call this function as well, so let's call it. I have target some pair, root, our initial node that we'll be testing on, which is also root, and the data. Now, firstly, let's put base case as we have been doing in all the other questions, that if our node turns out to be null, we do nothing and we come back. Otherwise, we traverse, we check our target some pair, we put a call to the left side, left subtree, to go on to the lower values first. To work in order, of course, we have to go left, then go to the right side, and then our data will remain the same. Now, we'll also have to put a call to the right side. And to calculate a complement, we will simply do this thing called data minus node that we have at the moment with us, dot data. This will be our complement. And so we'll see that if our node dot data, if it's less than the complement, that is, if we are still going in ascending order, because the values can repeat in descending order. If we have 25 and 75 as our pair, then 75 and 25 is also a pair, right? Technically speaking. But we don't want that. We only want the increasing order pairs. So if the value is less than the complement, we find our complement. And we find it starting at the root. That is why we have passed this root here. And if we are able to find it, that is, if we find out that our complement does exist, we print our pair, that is node.data, and then our complement. Otherwise, we ignore it. We simply go on to the right subtree and calculate our values there. And that's basically the code. Other than that, we just need to implement the find function. It's pretty simple. Public boolean find. Since we are returning a true and false value, we have our root with us. Let's call it node for the timing. And we have our complement. Since we're looking for the complement, we'll search and we'll check if our current data, sorry, if our complement is less than the data we're on right now, the node we're on right now, we'll go on to the left subtree and check it there. Actually, let's check in the right subtree first. Not that it matters, to be honest. We go on to the right subtree. If our complement is larger than our current value, if our complement turns out to be less than the data we're on, that means the complement could be found on the left side since it is a binary search tree. Otherwise, we have found the value, so we return true. We also have a base case that if our node turns out to be null, that could mean that our value wasn't found in this particular section of the tree. So we return false. And now we see if this code runs properly or not. Before that, let me check the output. Okay, the format seems to be correct. And we have made some mistake in line 43. And we have not returned it. We don't have a return type. That would be void since we're not really returning anything here. We're simply printing the values. And we need to make our find function as static. And we are missing a return statement somewhere, and yeah, if none of that works, we return false. All right, so the problem seems to be here. We haven't really returned our find function, the value from our find function, so we don't really know if we're able to find the complement or not. So let's see. Okay, compilation error in line 42. We don't really need it, I think. Let's just remove it altogether. We don't really need it. Let's try it out now. It's accepting. Let's try to run our test cases and see if our code is working fine or not. It is. All of our test cases seem to pass, and that's how you calculate the target sum pair in binary search tree. Thank you so much for watching. If you found this useful, drop a like, drop a comment, subscribe to our channel. Again, thank you for watching.